Hi folks, I'm going to explore fast in the command line today and show you a few tips and tricks to let you also build something with it. So let's start just like looking for the most common expression that you can use on fast. That is, for example, let's jump into snippets. Here I have a bunch of different SQL files. So for example, if I do here cat on, for example, cx.sql, I have this file, and I can also say fast here, and then fast will have a few options. It can and I can use an expression here. So for example, I can say fast underscore on the cx, and then you see that it will just bring the file and everything that matches underscore. So underscore is an expression that says anything that's not new. So any known new element, any known new abstract syntax tree element will be matching here. So as you can see here, it matches it a few times, even for like some empty elements. And you can see that this is the way that you can just like search in the command line for these things. And then like underscore is hard because you really don't know, but you can also put, for example, a minus minus AST, and then you can get the AST representation, so you can build some more interesting things here. So for example, let's say here you can see like select statement. So if we come here and say select statement, we convert minus dashes to underscores because this is easier to do. So for example, here you can see select coming in different ways. For example, table is also select, and you also have like inserts that are using select. So it can grab the elements and will bring the node related to this. And this is just the basics, and generally you start like you need to know more, you need to go dive into the details, and prototyping is the easiest way to go. So my favorite way to use it is with pry, and this is already integrated. So for example, let's say I want to go into minus minus pry mode here, and then I can just see here, for example, results here, and then I can see, for example, result.source, and I can jump into the next, for example, result, and then here I got like a more complex function call, and then I can also learn from it. So, for example, this is a this is the source of like a bigger tree, and it's matching the tree because like this is a root node, and then you can see the source behind this root node here. So when you start looking for these results, for example, let's say here you see like this is a function call. So, and you can see here that this is a select of target list of something that has a func call, right? So probably we can just like filter down only select queries that are using a func call, right? So if we want to build this, we can just exit from this command line with this, and we can be improving this select statement. So fast is done for prototyping, so you can open the parents and you don't need to close it. That's like a convenience that I just left behind because I was like, oh, that's just for prototyping, I don't need to close the parents. You can, it will not be validated, but yeah, you can do it. So the idea here is that we are going to go to target list, target to func call, and then probably we can say here select res target, and if this is correct, I already did something wrong here. Oh, we have target list in the middle. So when we don't need to know, like, oh, this doesn't matter, res target or whatever, we can just keep going deep here, and then how many levels we are going deep here, res target, vol, func call, right? So we are going to 1, 2, 3, and then we have func call. 4 levels, 3 until 4, 1, 2, 3, func call, and now if I forgot one extra level, and here we are with the result. So here you can see that we have 2 select statements with func calls, and we got it in a very easy way, right? So that's one thing, and maybe we want to standardize some types of like SQL, or we want to investigate something. So now you have exactly the data that you have there, or if you want to do some refactoring, you can also learn and explore here. So for example, if we want to do some refactoring, we could explore the options here. So with pry, so let's say we got this result here, and then we have like result dot source. So if I do puts here, you can see it's a create hyper table. So let's say we want to change the val of these sticks to something. So or even we want, let's say we rename hyper table to super table or something. So let's say we can just go to this node. So we can get here result dot replace, and then we can say here replace string svol another func. Let's call it create mega table. and then we can just see it when we got the result. You can see that it's, oops, sorry, I got some error here. So let's see where it is. So you can see here create mega table. So it can be refactoring the code in a context and helping you to be more precise when you are building or refactoring some large scale of SQL files. And then instead of just using like regular expression rules, you can just dive into these nodes and target them to something specifically. This is a very basic idea that you can use, and this is a small refactoring, and as you can see here, like in what we did here, we just did this result.replace, which we use some expression, and then we put some second param here. And this second param is basically something that is worth exploring, but let's just jump in some smaller examples so we can explore it a bit better. So if we say here parse SQL, for example, and then I say select one, right? So I have this, so I can do a replace here of the eval with, for example, 2, right? oh, I need to say it in a string mode. Sorry. Yeah. So as a string mode, you can say that it will just exchange the IVAL internally. Okay. But let's say you wanted to do something else with the node, or like insert something before or after. So this is just a shortcut for a function here that you can do for every node that you find. So you can do replace of the node location expression with some other value. So let's say here, for example, 3 again, another value. That's a different one. And this is exactly the same thing, just like rewritten in a different way. So we assume that you are using node location expression, but you can also use different functions here. You can use like insert, or you can be exploring all these functions. So what is the node location expression? So let's do some exploration here. So let's create AST as a variable, and then when we call here AST.location, you can see that it's a parse source map, and this parse source map is like relating to every expression, and every node can have like a sub expression, and they can also have their own position. So for example, the location here is 0 to 8, okay? And if I go here to the val, for example, let's say first val, and then I get the location here, this will be 7 to 8. So this is so here I can also say source, for example, and then we will see that the source correspond to that location. So these are all shortcuts to get values from the abstract syntax tree, bring it to Ruby, and replace and reuse it. So I hope you enjoy this first part of the journey, and now it's time to have some fun and overview a nice experiment that I'm building here. So the idea I was thinking here is, for example, if I just go to this CX file, you can see here, for example, some stuff are like camel case, other are not. So I was thinking like I would like to build and explore this as an opportunity to build like a format SQL thing. So I was building this format SQL, and in the format SQL thing here, the idea is like I can pass here table, for example, and then like some code, and it should be able to just create it. And if I say, for example, here like select star from B order where C order by E1, for example. And then you can see that the code is coming like in a very beautiful way and in a very easy to digest. So as you can see, I'm also using fast here. That is the same command line that we were using before, but with this dot format thing. And this is an experimental thing that I'm building through a fast file. So here in my fast repository, I have my fast file, which I already have a few functions that shows like shortcuts for me. And this, the latest shortcut I'm building here is this format SQL. So it both works with SQL files, or also, so for example, if I go here into my code / snippets, I can say fast.format SQL cx. Let's get cx here. .SQL, and it will to be formatting and replacing, and you can also use with strings. And the idea here is a bit different, but let's just go and explore it together, because this is very nice and an interesting thing. So fast is just like a wrapper for like giving you access to our internal of fast here. So you can just use, for example, you can ignore this public if you want, and you can just have a plain internal module of fast here to be exploring and building your custom script. So in this case, I'm just thinking like, oh, this argument is a file, or this argument is something, so I will parse the SQL in memory or get it from file, and then I will replace everything in the AST, whatever, so whatever will just get the root node, and then I will just navigate into the source buffer and get the tokens to understand what are the reserved keywords. And then when I get the reserved keyword, I will build a special range for this reserved keyword, and then we'll upcase it. So it's not that hard, and it's very simple. I also have like a highlight, automatically highlight for SQL. You can just use and inherit from the fast command line. And with these like 25 lines, you can just build your own SQL code formatter. So let's just jump here and put some debugging to show it in action. So let's put binding pry here. And if we go to the command line here, I can say fast format, and then we can see here SB, that's the source buffer. And the source buffer here is the most important thing to learn, because here you can see how the tokens are organized. So as you can see here, you can see reserved keyword, unreserved keyword, no keyword, and so on. So if you check the code that we are building here, we are basically navigating on the tokens and checking, oh, this token is a reserved keyword. Oh, yes. And it starts from the 30, or for example, here from the 24 to 29. So I'll get this and build a search range from this special slice of the buffer, and I will replace this range with a new upcased version. So that's how it happens. We could even validate if the source is already upcased. We don't need to do that, and we don't need to do the replacement. But this is a small, short example to get you understand how powerful is this and what types of things you can build on top of it. So, and for example, now if we just leave it, it will just cross all the words and make them available. So for example, as you can see here, buy is not a reserved keyword, it's unreserved, but this is a different token. So for example, maybe we could validate some tokens that we want to put there, and then we could make it even more advanced. So let's just do some dig deep and implement something, and then we can just make it in a very nice way. Okay, so let's put the token buy, and vim fast file, and then here we have the reserved keyword. So I'm thinking about putting here eligible keywords, and this is one, and then I can also say eligible tokens, and then I can use here buy. Is it buy? Let's get here. Buy. Yes. Okay. So for example, yes. So okay. Okay. So buy now is there. Okay. Okay. And then now I can say here Uh, Eligible tokens include or eligible tokens include. This is a good suggestion, but it's not right. In a token keyword. Oh, I'm so sorry. I just it's token and keyword kind. Oops, for some reason. Okay. Yes, so if these are included, we are going to make them also work. So now we have the reserved keyword and also buy, and then we can just add more things here as we want. So let's see if it works. Yay! And now buy is also upcased. So that's a very nice way to start thinking about like maintaining SQL in a more sane way, and also like if you have like a very large amount of SQL, it can help you in several ways. I hope you enjoyed the video. If you have anything to add, any ideas or things to build that or examples that you want to build, feel free to ping me. I am very excited to talk about it, to do some pair programming and be moving more and more interesting things about it. So thank you very much. See you around.